Yeah. Why would you call them custodians?
Yeah, why are janitors called custodians? Yeah.
Yeah.
If you play Warhammer 40k, like custodians are like an elite force of like the Emperor's like protectors. Like like the Watchmen basically. Anyone here play Warhammer? Dude,
No, I used to, but I mean, to be fair, some like janitors are pretty badass. I'm not.
That's true. Very true.
There are
some janitors
pretty
are
cool janitors out there.
Yeah, there are some pretty dope janitors out there for sure, dude. Yeah, I'm pull up an image of like the custodians from 40k. Custodians 40k. Yeah, like look at these people. These people are just like badass, dude. These are the custodians. They're seen as like the Emperor's like personal like guardians or something. Adeptus Custodes. You got these like dope ass like Praetorian like gold outfits and stuff, dude. They're super cool.
The point is that's what custodian means. It means watchman.
Yeah, watchman. Yeah.
It doesn't make any sense in that context.
Maybe the janitors are the watchmen though. You know, they do see everything that goes on, right? I would imagine so. Bum bum. Oh, what's Julie? What's up, Julie? Julie found my Discord. Hi, Julie. Let's see. So let's see what happened over the weekend. No, Julie's cool. I meant no, Julie's fine. What was it? What was I talking about? Oh yeah. So over the weekend we did a chess tournament, right? That was super fun. And then on Sunday we did what was it? A math watch party for all the videos they're submitting for this 3 blue 1 brown stuff.
Oh yeah.
Yeah. Julie says, "Say hi." What's up, Julie? And it looks like that's happening for the rest of the week as well. So we might do another day of this, of these fun like little math watch parties, because I enjoyed like one of them, like that video about the what was it, the gambler's fallacy of how like a 50-50 coin is not always fair, or like it is fair, but you don't always like the lead doesn't swap. I thought that was super cool.
Oh yeah.
I liked that video.
It's funny that he mentioned that. Actually, we did this thing in year 5 or year 6. I can't remember exactly. We were told to flip a coin and record the results.
Okay.
And because I could control how the coin flips, it was always heads
No.
and tails, heads and tails. And then they never believed, the teacher didn't believe it literally until I showed him, oh look, I've just done it 10 times.
Oh man. That reminds me of, I don't know, does anybody watch Foundation? I recently got into Foundation. It's a, it's based off of Asimov, who's like the grandfather of like I would say sci-fi, right? What do you do? iRobot, but Foundation apparently was his original, I think, work of like textbooks, and it is hilarious to see how I thought everything was like based on Dune. I was like, oh, Star Wars, like all this sci-fi stuff is based on Dune, but then you go watch Foundation, and you're like, oh wow, no, Dune is based on Foundation. Like Foundation is like the original OG sci-fi text, and it's crazy that it was written in like the 40s or 50s. I don't know, but they also talk. There's a character there who can like flip a coin and like can always predict what it is, which I think is like kind of funny.
It wasn't that I could predict what it was. I could just control the coin.
Right. I see. You could affect it by like how you flipped it.
I can hear how many times it's spinning, and then just
no, stop it.
How many times to make it spin?
Wait, how are you doing this?
How? Because it makes a frequency when it spins.
Oh my god, dude. Sensation is like this is your mutant power, dude. You're like one of the X-Men now at this point.
You're not aware how good my hearing is.
Yeah, apparently. Man. All right, let's see. We got a question in the chat real quick before I go into scheduling stuff. Monkey Man says, I have a question. So I'll be looking to do an undergraduate research assistant next semester. I'm going to email relevant professors and PhD students about volunteering. I did a little bit of work in the past, but I want to take it more seriously and actually be useful going forward. Do you have any advice on skills and stacks to work on? Thanks. Nice. That's a great like motto in life. Instead of asking people like, what can I get from you? It's like, what can I do for you? Like, what can I provide to you? I would say professors and PhD students love people that know how to like analyze data. I would say that's like a very useful thing to do. So if you could build up some skills in writing code, and also just like understanding what types of analysis we do for data. There's some good books on this. I'm trying to let me think about it. It's like math for physics data analysts or something. It's a book. Breskles, you know the book I'm talking about?
I may.
It's like, oh man, dude. This is it. Here we go. This is it. This is a great book.
I've seen it. I haven't read it.
Yeah, if you want to get a copy of this, or I'm sure you can find a PDF somewhere online. I remember this book was like the Bible in my physics lab, because a lot of times you're taking in all this data and you get confused of like, what's the point? Like, what should I be looking at? What should I be analyzing? And then like, what is significant and what's not? You know, sometimes data is erroneous. Sometimes it's actually means something. And statistics is this beautiful language we came up for like determining, I think, like truth of what data is useful and what is not. So Lindemann's melting law, I don't know what Lindemann's melting law is. What? That sounds very difficult. We can look it up.
I suspect it has to do with melting. That's my one theory.
Wait, isn't Lindemann a type of chocolate? Right? Lindemann chocolates?
Also the lead singer for Rammstein.
Oh yeah, Till Lindemann. Yeah, he's dope.
Good job.
I love Rammstein. Rammstein's sick. But anyways, okay, so yeah, so this book, oh, Lindor, you're right. Maybe that is who I'm thinking about. I thought Lindemann also made chocolate. Lint. It's Lint. Okay. All right. That's how much I know about my sugars. So, yeah.
I eat too much chocolate, fuck's sake.
Same. But yeah, if you want to get this book and like read it, it's super useful if you can go to a professor or PhD student and say like, hey, I could help with your analysis and I could provide, you know, useful techniques to determine whether your data is saying like useful things or whether it's just noise. So yeah, data analysis and manipulation. Yeah, don't do data manipulation. Don't say that. Manipulating the data is not great.
Actually,
but yeah.
What if his professor is like a flat earther? Then you need that. Like then that's a valuable skill.
You do need to manipulate the data at that point. Yeah, I agree. Yeah. Let me see. Lindemann proposed that melting occurs when the amplitude of thermal atomic vibrations becomes a significant fraction of the Lindemann parameter. Oh, okay, cool. When the vibrational arms. Okay, cool. What does that mean? Well, I mean, that's just the definition between like solids, liquids, and gases, right? Liquids have like more, I would say, like intramolecular forces that are kind of holding them together. And especially solids. Solids are in a crystalline structure. And that's what, from what I see there, when they talk about it like a crystal lattice, in order to go from a solid to a liquid, you need to destabilize that crystal that's like holding everything together. And yeah, temperature is related to the vibrational frequency of the individual atoms. So melting occurs when eventually that temperature, right, or that frequency of vibration gets to a certain point that, yes, it starts to break down the lattice bonds between stuff. Can I use that to compute the melting point of tungsten? I would just look it up. Equity says, I saw the video
I feel like
you're
that's
in.
more metallurgy.
Yeah, that's more like alchemy and stuff. Yeah, this is funny. I am becoming recently like, I've had a couple of people hit me up. This is like resurfacing now on the internet. This interview I did with a flat earther. How did I get invited? They just hit me up, dude. This guy's name is Jack Gordon. Called me up and said, hey, I'm gonna be in LA. Do you think you could like debate a flat earther for me? I need like, originally it was like he was really looking for someone like from NASA, because that's like the clickbaity thing. And I told him straight up, I'm like, I'm not a NASA scientist. I mean, I did plasma physics. And then he's like, oh, well, maybe did you get like some funding from like NASA? I'm like, I mean, maybe indirectly at some point, but but no. But yeah, it started hitting the. I did this thing back in, I think April, right, or like May. It was a long time ago. I thought I should.
It was a while ago, yeah.
Right?
You did.
Yeah, it was
definitely did.
Yeah, and I told you guys about it. It's this video that is now making the rounds. It's the people are seeing it now on like Instagram. I think that's the algorithm is like for whatever picking it up. To be perfectly honest, it's a pretty shitty video. Like, it's not good. I mean, I understand like the intent behind it and whatnot, but the editing is, I don't know. It's you don't really get any. It's just bait, is what it is. There's not really any substance to it, and
Yeah,
a lot
that's
of
what I noticed. It was
right.
like, not a whole lot to it.
Yeah, it's just for clicks, and I get it. Because dude, we were together. Me and this guy, Nathan Thompson is his name. He's actually a cool dude. I mean, he's wacky. He's fucking out there, but like as a human, like he's not that terrible of a person. Although I did see like some quote on his Facebook the other day of like, wouldn't it be cool if like right before D&B dropped, like it dropped into like one of Hitler's speeches? I was like, oh no, dude, no. And dude, someone like immediately in the comments was like, oh, so you think Hitler is cool? And the guy's like, I think he's just misunderstood. And I was like, no, you can't say that, Nathan. Anyways.
Alright, I'm going after that one.
I know, right? Yeah, so anyways, this video has been making the rounds on Instagram, and everyone's been like, oh my god, that's Dr. Gold, that's him. And yeah, it was a fun experience. I had a great time meeting the dude. We were together. We filmed for probably 5 or 6 hours. The unfortunate truth of the internet and like algorithms is they had to cut it down into 10 minutes. And they really just wanted to feature all the wacky fucking things that this dude says about flat earth, and kind of ignored all the counter arguments I had. They were just like, yeah, whatever. Like science isn't like attractive and rage baity. They're like, but this dude claiming about the firmament or like the universe is on these grand pedestals, like this thing here, he believes this like is a real rep. He brought in like these columns here and this thing, and he said this is actually how the earth is. Like the earth is on these like these Greek columns, and there's a thing, and I'm just like, oh my god, what?
Right.
Anyways,
never invite me to these places.
I know. Yeah.
Within 30 seconds, I would have lost my shit, picked up one of those Greek columns, and beaten to death with one.
Oh no.
Yeah, exactly. I mean, good. Equity says, why didn't you tell him you should have put more of your arguments in the vid? Because it's really his channel. It's his creative direction. I mean, yes, I guess maybe I could have had a little bit more of a nudge, but I didn't see any drafts. Like literally, it just came out, and he's like, "Here it is." I was like, "Okay, cool, man." It would have been nice to have seen a draft first, so I could have like maybe had some input into like what the video was. But I mean, that's his business. It's his channel, and the comments definitely reflect that they were like upset at how he edited it. So I don't really need to say anything. Like the public will respond to it. So, anyways, it is what it is. It was cool. It was a great experience. I had a fun time. I wish the video was better, but whatever. What's up, Ethan?
How's it going?
It's good. It's
Where's
hot.
he going?
I'm trying to pump some water because it's fucking hot. I'm thirsty. Anyways, what's going on, Ethan?
Yep, I know it's worse here. But yeah, so I have to let you know that school started back up for me just today.
I've heard that for a couple kids that like school's like just starting now.
Yeah, so I have like 5 classes right now. I'm trying to see if I can add any, but
What classes are you
I saw
taking?
I'm doing operating systems, DUI programming, history, which to be honest, I just don't feel good about it. I'm also doing Spanish and philosophers, like studying philosophers and
Oh, that's cool. Spanish and studying philosophers. I like the, was it, you said DIY? I hope it was not DUI programming.
That's
What?
dope.
No, I said G, like GUI, graphical user interface.
GUI. Yeah, graphical universe.
Yeah, GUI.
Yes. Yeah, there we go. Yeah.
That's- Yeah, to be honest, I like my schedule, but and here's the thing: I tried to add classes, but my mother is completely against it still yet because like she wants me to finish what I started, and
I think
don't
you
know.
should. Yeah, we've been through this. I know you want to like go into one other like area of studying, right? But
Dr. Gold, this isn't
What's up?
like math related stuff. Like I feel like compared to the ones I want to join, I learn more from those compared to maths because I still learn nonetheless, right? The thing
Okay.
is that like I really feel like I could learn something like the titles are Power Fundamentals and PC Repair, which to be honest, I feel like will be super useful as a computer person.
Yeah,
And
PC repair is cool.
routing and switching, which is just like network stuff, network technology.
That'll get you a job for sure. Like knowing any sort of like networking skills will definitely get you a job. Yeah, I think for sure.
But then it's like, I might have just said do what you want. Like she's done with this argument now.
What's Sensation pulling up? Oh my god, just a fucking book of TCP/IP.
TCP/IP. Oh,
Dude, how is the book that thick, dude? What?
Real?
I feel like that's reasonable. I just got a book in today on Stern build theory, and that thing is thick.
Was this the post you said about like the guy she tells you not to worry about?
Not to worry about.
You know, that one was too funny.
Yeah, I ordered it, and it's 927 pages.
Jesus Christ, dude.
The table of content is 3 pages long, front
Yeah, I
and
think
back.
this is the one. This is when he said. He was like, what'd you say? You versus the guy she told you not to worry about.
Disqualified.
Sturm Louisville operators, their spectral theory, and some applications. Jesus, dude. And then this is Green's function, which is just like a little bit more chill. Wow, that's cool. Nice. Yes. One sec. Let me read through chat real quick. Monkey Man says, at least he didn't edit you to make you seem like you agreed. Agreed. Yeah. If he had put things in the video to like misrepresent my opinions, then yeah, I would have definitely put my foot down and be like, no, you can't make me look like an idiot. Like, but if he's just omitting my responses, then I'm like, whatever, that's your creative decision. Like, do what you want. And wait, yeah. Some people have started university already. UCLA will not start until like mid-September, but I know that some of the other colleges, like Breskles, when does A&M go back?
I start next week.
Next week.
Yeah. It's next week, right?
Oh no.
Yeah. So all that stuff starts pretty soon.
I want to say it's the 24th.
Yeah, mid-Sep. Yeah, it depends on whether you're on the quarter or the semester system. Okay, cool. So one sec. Let me. What's up, Ethan? Real quick. What's up?
I'm going to try and join them, but I just feel this uncomfortable feeling that how I'm just betraying what my mother said. It's like,
no, I don't think you're betraying what your mother said. It's okay. You're just deciding to like take classes you want to take. That's not betraying your mother. Would be like, I don't know, like running off with like a gypsy or something, and then like, you know, selling yourself to the circus. I think just wanting to take other math classes that's okay. You're fine.
and math classes, no, I can't do it, sadly, because then the major, the PC repair, and the network class will clash with those, and I can't work with that. So
Okay.
I want to do PC repair and network, which to be honest, it would seem like I learned a lot more compared to even one math class that I joined. But for the math, I could just do independent studying.
Sure. Yeah. No one's ever gonna like take away your free time to go learn things on your own. And honestly, like with the amount of resources you have on the internet, you don't really need to take formal classes. Formal classes are nice because they give you structure, they give you motivation, and they give you a nice piece of paper at the end where you can say like, hey, I did this thing.
Really?
But if you honestly want to learn those skills to, again, get a job, or in this case, Monkey Man wants to like get into research, you don't need to take classes. You can if you have the discipline to go learn it yourself, you can go do that. And that's not betraying your mother at all. That's in fact that would be probably make her happy, I guess. Yeah.
All right, well, I'm done for talking for now. I'll continue with this when I ask my question, if that's
Cool.
okay.
All good. All right. Yeah. All right. Let me. Yeah.
Just
Zoe's summer class is true. All right. Let me one sec wrap up. Couple announcements I had for the server, and then yes, we're gonna. The queue's already 5 questions long, so let's go into some questions pretty soon here. But yes, if you are interested in watching more of these fun math videos and the judging, all of that has been put on our calendar now by Penn Center. Thank you, Penn Center. So again, the website for that is always actualofficehours.com, and if you go click on the streaming schedule, you will see all of the events happening. So the gold ones are our streams. These are more like, again, the office hours, like we help you guys out with math and science questions, but everything in gray is going to be all the math review streams. So the math video competition review streams. So if you want to see all these other awesome streamers who are watching these submissions for this big math competition and see how they're rating things, everything here is in gray. We might join. I might start doing some streams on Wednesday, but for the time being, that's where they are. So go check them out if you want. All right. With that being said, I don't think I have anything else like super important, but I do see there are a lot of questions. So let's go help you guys out and kick off the stream. All right. All right, welcome everyone to Actual Education Office Hours. My name is Dr. Gold, the stream that helps you out with math, homework, science homework. All sorts of fun stuff. We've been kicking off Monday. I love seeing everyone show up on Monday. It's great. And I can tell things are going to start really ramping up because the school year is starting. People are coming out of the cocoon that was the summer, and they're like, oh, now I need to go learn things again. Yes, I am. Yes, yeah. Let me start TikTok. Well, actually, I just booted up TikTok. It was taking a little bit. All right, let's see what we got first in the queue here coming up. All right.
Actually, one question that you can answer in 10 seconds or not.
Okay, 10 seconds or not. What's up? What's 10
What's the
seconds
specific heat capacity of water?
4.186 joules per degree Celsius, something grams. 4.186. I'm pretty sure it's 4.186.
Okay.
Yes. That means
Iron?
it takes 4.186 joules to raise the temperature of 1 gram of water by 1 degree Celsius. Oh, 1 calorie? Yeah, that too. That's also true. That is also true. Okay. Let's see what we got in the queue. Couple questions. All right, great. Let's spin the wheel and see who we're going to work with first here.
Let's go gambling!
Hold on, let me get the TikTok chat working. Equity, you're number 1. Congratulations, Equity. You have won the first question of the day. Let's see what you got. Ooh, all these limits. That's fun. All right. Can you let me know a couple of them you want to do?
Oh, may I also help? May I also help with this? I want to learn some calculus.
Calculus is great. Yeah, this is limits. This is like early calculus.
This is early calculus. Calculus 1, not calculus 2, right?
Yeah, this is Calc 1. This is the beginning of Calc 1, or it would be the end of pre-calc, honestly. It's probably
Yeah,
would be.
this is Cal 1.
Yeah. This is a really fun one. I already know.
Right?
I already know this one. This is a great one. Or Equity, can you pick a couple that like you don't get or you don't understand, and then I'll do those as well. But just let me know.
I hate the trigonometric functions though. Like you have to know their what was it? Derived them? Derivation? I don't know.
You have to know a lot of the identities and stuff for sure. Yeah. So anybody, a lot of students come to me. They say, "Hey, Dr. Gold, I'm going to start calculus this summer or whatever. Like, or I'm going to start calculus in the fall. What do you think I should study like before I have to go do it?" And I say a lot of times, learning trig, like relearn your trig. That is super important for getting good at it. Yeah, exactly. You can't use L'Hopital's. Not really.
L'Hopital?
Yeah, L'Hopital's. Yeah, they want you to use trig identity. L'Hopital's is when you get an indeterminate form like 0 over 0, which I guess technically you do here, right? You do, and I think L'Hopital's actually would work here. But they haven't learned L'Hopital's yet.
I'm pretty sure it does, but yeah, most teachers hold off on L'Hopital because you got to learn the actual limits. They teach the limits so that you can understand the derivative.
Isn't that like
you can't really...
isn't it El Hospital,
exactly.
not Las Love?
No, it's L'Hopital. It's French. It's fucking weird.
What the hell, bro?
Yeah, La Hospital. Don't say La Hospital. Don't say La Hospital, please.
L'Hopital's rule.
The reason everyone's getting confused is because it's L apostrophe.
It's an identity.
Yes, but there is also like an H in there, I think, at some point, right?
I think the signs
the French don't
identity is
pronounce H for
cosine.
shit, so.
Then like
Yeah, the French don't pronounce anything for shit, dude.
Oh no.
Okay.
Why does this word have so many letters? And you say
Okay, here. These are some useful. Here's some useful identities that you should just know. You can go.
Y'all
prove
have
them
high
if you-
standards for French people.
Can't you do sine is equal to cosine and then cosine is equal to a negative sign?
No,
Like,
that's
isn't it something
derivatives.
like that?
No. We're not doing anything with derivatives. We're not doing any of that. We're just doing limits. Okay. Dream, you're getting there. You're getting close, dude. It's exclamation point submit. There you go. All right, this is the main one you want to use, which is the limit as x approaches 0 of sine of x over x. That's always equal to 1. So the reason why this one is weird is because it's sine of 7x over x. And you're like, wait a minute, this has nothing to do with 7x in it, just has regular x. So this is where you want to use like some sort of u substitution. So instead of doing the limit as x approaches 0 of sine of 7x over x, what I'm going to do is I'm going to make a substitution, and I'm going to say let 7x
X
be
equal
equal
u?
to u. No, not x equal u. You say let 7x equal u, okay? Then,
Dang,
if
all
we
right.
rearrange for x, we get that x is equal to 1/7 times u. Okay?
See, where is that coming from? Where is that coming from? And I
Well,
don't understand u substitution at all.
So u substitution is you're just identifying something in the equation and you're calling it a different variable. So for instance, I don't know again what the limit of sine of 7x over x is, but I know what the limit of sine of something over something is if it's just a regular variable. So I'm calling this whole 7x. I'm just calling it u. But then if I call that whole 7x equal to u, I need to also come up with like, wait, what's just regular x then? Well, you can rearrange this, right? If you divide by 7 on both sides. And then that gives you that x is equal to 1/7 u. Right?
Okay.
And then here's the key thing. So then we also need to fix the limit here. So if x goes to 0, all right, what does u go to? Because we're so 7x here, right, is equal to u. So think about it. If x goes to 0, what does u go to?
0 as well, right?
Yes. Good job. Exactly. So now I can rewrite this whole limit as the limit as u goes to 0, right? Because x goes to 0 is the same thing as u goes to 0. And then this is going to be sine.
Sine of u.
Yes, good. Over.
1/7 u.
Good. Yeah, 1/7 u. And then here's the cool thing. Dividing by 1/7 is the same thing as multiplying by 7. So I can rewrite this whole thing as 7 times sine of u over u.
Sine of. Okay.
Yeah, okay. And then here's the other cool thing about limits. So anytime you have just like a multiplicative thing just happening to your limit, if it's happening to everything inside, you can just pull that outside. So instead of saying...
Oh, goodness.
So 7 times the limit. Yeah, this is totally legal. As long as this is just a number just multiplying, you can pull it outside. Now, this looks exactly like this. Exactly.
Like that.
Yeah, do you see how it's variable goes to 0, sine of variable over variable?
But then that means that it could just simply be equal. Simply like equalize to 1.
This is equal to 1.
It's just
right?
7.
Right, good, exactly. So this is all equal to 1, but then you still have 7 times this. So then 7 times 1 is equal to 7. Yeah.
Oh.
So.
This was your substitution kind of sounds a little tricky though. A little.
It sounds complicated, but it's not really that complicated. And yes, Stan, this is there a way to algebraically do this without u sub? I don't think so. I think u sub is algebra.
I mean, u sub is algebra. You could just multiply by 7 over 7. If you multiply by 7 over 7, then you get 7 times sine of 7x over
Sure.
x.
I see. So if you did this over this, right? And then you're like, oh, well, look, it's sine of 7x over 7x. Technically, then this would also need to be 7x. And I don't know, it's kind of weird to just start like multiplying
I don't think it needs to be 7x in that limit because we're just multiplying by 1 on the inside.
Yeah, no, but I'm saying, but by the definition of the limit here, right? These all have to be the same variable.
Well, I'm not saying like a substitution in this guy. I'm taking literally just like multiplying by 1.
Right. I get that you're multiplying by 7 over 7, which is the same thing as multiplying by 1. So that eventually this would look like 7 times the this limit as x goes to 0 of sine of x over 7x. It's just I feel like this technically needs to also be 7x.
I don't think so.
I don't know.
Because we're technically not doing any sort of substitution, so our variable isn't inherently changing.
Yeah, hold on, Ethan, 1 sec. Yeah, it's just, yeah, I get it. I get that you're saying like, oh, well, look, this is, but this is different is the issue. This needs to still be 7.
I get what you're saying.
Yeah, it still needs to be 7. Yeah, your teacher taught
There's
me
more
just to multiply by
formalism,
7. And what you got to do the other. Yeah, what do you mean to the top to the bottom? Sure. Yeah, the issue I have with that is that the bounds on the limit or whatever the limit approaches needs to also change. Because sometimes you make u substitutions where instead of something approaching 0, now it starts to approach like infinity, based on like what the thing was that happened. Okay, Ethan, what was up? What was your question?
I know this may sound like a stupid idea, but like,
No.
could you not just use direct substitution and get an answer from there?
I mean, I think u substitution and direct substitution are the same thing.
I get them.
Yeah, there's nothing special about you.
There's nothing special about
You
it.
just-
Yeah.
Shows you.
I just chose you. U's just like a cool thing. All right, let's try this one. What app am I using? Yeah, group roll, Juji, if you're wondering. Okay, so this one, this is kind of a similar thing. We're just gonna split this limit into two things. So, if you have the limit of f of a plus f of b, this is the same thing as
Limit.
Limit
FFA.
f. Well, actually, I should have made these. Sorry, I should have said sorry. That's what I meant to say. 1 sec. F of x plus g of x. This is the same thing as the limit of f of x plus the limit of g of x. These are all like the distributive and whatever properties of limits. As long as stuff is not like infinity minus infinity or like 0 minus 0 or whatever. But this is okay. So I'm going to split this into the limit as theta goes to 0 of theta over 2 theta plus the limit as theta goes to 0 of 3 sine theta. Good, over 2 theta.
All over 2 theta.
Yeah, and so what's this limit?
I have no idea. Like,
Okay,
just
well look
do
at this.
1 over 2 and that's it.
Yeah, there you go, done. Yeah, this goes away, right? And so now you're just left with the limit as theta goes to 0 of 1/2. And so that's just equal to 1/2.
Yeah.
And then this one,
in there.
this is
Can't you
3
just take the
halves.
3 out of there?
Exactly, yeah. Limit as theta goes to 0 of sine of theta over theta.
And what do I notice? Is that
what's that
how this is the exact same thing as what we did before.
Mhm.
Do it by 1 and then, it's just 3 over 2 or 1.5 if you wanted to do so.
Yeah.
And
3
if
over
you add
2
the
times
they
1.
glitter,
Good, yeah.
if you do that, then that should mean that how it's just 2, yeah.
Yes.
Because, hey, don't do 2. Oh, wait.
Don't do the unexpected
two ti-
factorial.
It
But you know what?
technically is correct.
It still works. It still works. It's technically
Yeah,
still
okay,
correct.
2 factorial is still correct technically, yes. Okay, there you go. Yes, so that's how you do that one. That's again just splitting
Pretty
limits.
easy.
That one was pretty chill. Let me see, 25, 27, 28, 33. Maybe I'll pick like 1 or 2 of these just because the queue's getting a little bit long. Let me just see. Is this
It's like
not?
we're doing math.
This is already done. This is a known one. Equity, by the way, for 28.
Yeah.
Yeah, that one's
That
known.
one's just easy. Questions us.
Um,
Maybe 26. That's
This
a
is
little big.
30 is another known one. Yeah, this is similar.
Oh, just 3 over 2?
Yeah, so this one would just be 3 over 2. This one would just be
What
equal
about
to
like,
1.
what if you do 26?
Let me see the other one I was
26?
asking for. 28.
Off of what,
Oh,
yeah.
33. 33 or 27. Let me see. Bum. Okay. Let me do 33 real quick because I think 33 is also like kind of pretty chill. So we gotta remember what cotangent is. So
I don't know what that
cotangent of
is.
theta. Well, what is that? Do you know how to express it in terms of sines and cosines?
No, I do not know how. I don't even know secant or even cosecant or cotangent at all.
Well, those are just inverse reciprocals of sine and cosine. Okay, so cotangent is cosine of theta over sine of theta. This is kind of a known thing. So now you have the limit as theta goes to 0 of theta times cosine of theta over sine of theta. Okay. Huh. I think I'm tempted to like write this and like invert it. Yeah.
Sine of theta equals the cosine over
Yeah.
theta.
Here's I want to say this is the same thing as the limit as I don't know.
Theta 0.
I want to say this is theta over sine of theta times cosine of theta, which I think is the same thing as saying the limit as I want to flip this is what I want to do. Right, this is the same thing as the limit as theta goes to 0 of sine of theta over theta to the minus 1 and then times 1 over cosine theta. Am I allowed to do that?
I have no idea.
I want to try doing this without doing L'Hopital's rule. I know I could do it with L'Hopital's, but they haven't learned L'Hopital's yet. They've just done limits. Wait, why 1 over cosine theta? Oh, yeah, sorry, whatever. Sorry, my bad. Yeah. I mean, this is tricky, though. I don't think you're allowed to say the limit of f times g is equal to the limit of f times the limit of g, right?
But can't you do that? Can you not do that?
No, that's not.
Yeah, that's illegal. You're not allowed to do that.
But that sounds like logarithms, you know? The log of a times b is equal to the log of a plus the log of b. Like, can't you do that? Like, why can't you apply it here?
Jeff says you can do it if both limits exist and are not equal to 0. Okay. All right, so maybe you can in this case. So, yeah.
But that's just 1. The entire thing's just 1 over
right,
there.
this thing is just 1. This is just 1 to the negative 1.
The negative 1 won't do anything.
And then this is cosine of 0, which is also just 1. So the answer is just 1.
Wait, what? How do you know it's cosine of 0? What?
Because it says theta goes to 0, and this is cosine of theta. So cosine of 0 is 1.
Dang.
I wonder if that's legal. Let me just ask chat real quick. That seems a little sketch to me. It's a little sketch to do it
you should do Google Gemini.
I have all of them. It's just I like chat.
No, it's 1. I guess it's legal. Wolfram says it's 1.
Wolfram says that's chill.
Yeah.
Okay. Yeah, cosine, and then so. All right, cool. So yeah, apparently that is okay to do.
Okay, cool. That's it.
Okay. Yeah, and then there was one last one he had that was actually interesting. What was it? Was it 20? No, 1 sec. 27.
I want to say 27.
Yeah, let's do 27. I think 27 actually might be cool. But actually, I know how this is gonna work. This is actually Okay, watch this. Oh, come on, PC, don't die on me.
You just do. Well, isn't one of them just going to be 1 instantaneously?
Can you briefly derive why sine of x over x goes to 1? I think that's the squeeze theorem. That's the squeeze theorem, right?
Yeah, it's squeeze theorem.
Yeah, Frank, have you seen the squeeze theorem before? Let me pull it up real quick for him.
Craziness.
Well, it has to do with this. Okay, so 1 sec. Yeah, you know that sine of x is always in between 1 and negative 1.
Sine of x.
Yeah, what do you do here again? But I want to show like why sine of x over x goes to 1.
Well, wait. It was.
1 sec. I think what you do is you divide both sides by x, and then you take
you
the
click
limit.
On the
does
link
that have
I
it?
just sent there.
Let me show
proof
you.
of it in there. Yeah.
1 sec.
Yeah, it's a bit further down.
Yeah, where is it?
It's right there.
Using the above inequality, cosine of x is less than sine of x over x is less than 1. So first you have to show that cosine of x is always less than sine of x over x. That's the first one you have to do. Right? Oh, that's cool. I thought I remember it being something a little more chill. I remember this is like kind of what you start with. And then Oh, I remember.
I think that's to show that sine of x over x is...
X, as x goes to infinity, is equal to 0. Right? That shows that this goes to 0 as x goes to infinity. Which is, okay, kind of silly, though. Okay. Again, squeeze term, they say that, like, cosine of x is always less than sine of x over x, which is always less than 1. And then, yes, in this case, if you take the limit as x goes to 0, this becomes 1, less than like something, and then also 1. So this must also goes to 1.
Dang.
Yeah. The way you can show this, yeah, Kaushik has a good idea here, but if you look at the series representation for cosine and sine,
Oh gosh, no.
yeah, they're basically the same. Yeah. I mean, it's just like there's one's the even terms, one's the odd terms, and you just instantly show that, like, hey, if I divide by x, instantly I'm gonna get like yeah.
You know, Totoko, like, I really hate series because sometimes I look at them and, like, they just contradict each other. Like, how come the sum of, like, 1 to infinity is equal to some, like, negative 112 or negative, some random negative number when it keeps going up? Like, that is...
Well, I mean, the negative 112 is it's a analytic continuation. It's kind of this, like,
it's just not correct. That's not correct.
It is in the sense that when you see it like posted on video, they don't explain it fully, and they don't explain that we're not actually saying that it's this sum, but we're saying it's
this is actually an interesting identity, though. It's not correct in standard mathematics. Yeah, wait a minute. This identity actually kind of like bugs me a little bit. I didn't know this was actually true. Why is that again? Sorry, wait, what? Why is cosine? I mean, I can get it from like the unit circle. I understand that, you know,
Not the unit circle. Come on, not that big.
Well, as you go this way, right? Cosine goes down, right? Because there's less adjacent side to stuff, and sine goes up. And then I guess as you go this way, you're dividing by a number less than 1. Or actually, yes. Yeah. Okay, was it cosine of x is approximately 1 minus x squared, sine of x is equal to x? Where does that come from? Sorry. Oh, when x is small. Approximately. Yeah. But I'm wondering, like, where do those approximations come from again? Does it come from the unit circle? Was that the derivation they had it? I think that's probably where they had it from right here, right? Yeah, they do like areas of triangles. Wow. Okay. So yeah, Frank, it would take me a little bit more time to like prove the identity that allows you to prove that sine of x over x goes to 1. But it is a squeeze theorem argument. You can derive it from e to the... Yeah, we're not going to do this. It's going to take too long to do all that. All right, let's do this one real quick so I can move on to the 9 questions down the queue. Okay. Theta goes to 0. Of this, I want to say this is the same thing as theta plus tangent of theta all over sine of theta to the minus 1. Or do we think we want to multiply by an identity?
No,
or
I'd
like,
say that's legal.
Yeah, okay, cool. right, so
Because
then
you
this
can,
is
anytime you have a division, you can break the limit into the.
Can't you just
top
do
and
like
bottom.
theta over sine of theta plus tan of theta over sine of theta? Like, can't you do that?
yeah, that's what I want to do.
Well, wait, why didn't you just keep the original form? Why reciprocate it then?
Because I can't split things if this is on the denominator.
Oh, okay.
So this is
Well,
sine
I
of-
mean, if you really hated yourself, you
could
could
multiply by the-
technically do partial fractions and
yeah.
break it apart.
Partial
But-
fractions? No.
No, I'm thinking, but
partial fractions.
couldn't you have
Theta
multiplied this by
is
theta
ridiculous.
minus tangent of theta? I feel like you could have done that.
Nope.
Probably.
Nope. I don't care about that.
I don't think I want to do that.
That
I think this
that
is-
wouldn't particularly help a ton.
I think this is what I want to do because then this cancels,
Yeah.
and then I'm left with theta over sine of theta plus 1 over cosine of theta, and then again, this whole thing here is 1. This is also going to be 1. So then it's 2 to the minus 1, which is equal to 1/2. So I think that's the way to do that one. I get a little weirded out, like, doing them separately, because I didn't like split the limit here, per se. Oh, okay, actually, okay, yeah, wait. Yeah, sorry, I like Jeff.
My name is Jeff.
Jeff has a much better idea here. I like Jeff's idea much better. Yeah, because this to me is like kind of sketch. I don't necessarily like doing this. It works, but I'm not. It's kind of sketch in math land. Yeah, Jeff has. Yeah, no, we're not allowed to do L'Hôpitals. I know. Dude, I know the easy way to do this is to do L'Hôpitals, but this is an intro, like first week of calc. They haven't done any L'Hôpitals. They haven't even taken a derivative yet. So we have to do everything without L'Hôpitals. This is the correct way to do it. You divide top and bottom by theta. So now you get the limit as theta goes to 0 of sine of theta over theta, right? And then that's times 1 over, that's just going to be 1 plus tangent of theta over theta. And then, yeah, this goes to 1. This goes to 1. This whole thing goes to 1. So then you get 1 plus 1 over 1 plus 1. Or times 1 over 1 plus 1. So you also get 1/2. Oh, and for the sine of x over x, bound x between sine and tangent. Oh, that's another cool way to do it. Bound x between sine and tangent. Okay. I guess that's the same thing as like the... What were we talking about? I think it was this one. Yeah. Okay, cool. All right. Does that make sense, Equity? We did a bunch of yours here, but hopefully it's cool. I like limits. They're fun.
Oh, it just sounds confusing right now. Flip, man.
It's just a lot. It's a lot. Yeah, you're welcome, dude. Nice. Congrats. Okay. Ooh. Okay. Let me save all these to the server. You're not gonna do mine, are you? I mean, if it gets picked, maybe. Depends how difficult it is. Jeff. Okay, this was equity.
Let's do some real physics. Tell us about the Carrington event.
That sounds like something from like black holes or something. All right. Nice. Okay, so we'll put that question in our Discord. So again, for anybody who's watching, if you ever want to know like where the repository for every single question we do on this server, where it ends up here in our Discord. So under homework help, here's Equity's question. We apparently spent 27 minutes on it.
Yeah, because
We did a lot of them, and we were teaching some stuff, but I'll drop the screenshot in there for you to see as well. And there's also a link to go back and go through the recording. The one in chat, the one about the Lindemann thing, I think you explained it to us, no?
No, he said sine of t minus t over t cubed using trig identities.
Sine of t minus t all over t cubed? Yeah, maybe later. Yeah. What? Oh, I don't know. Could you do it using identities? I don't think so. The minus T is kind of weird. Oh, well, wait a minute. Is that just 0? No. One sec. Hold. One sec. You said sine of T minus T over T cubed. So
Goodness
what is
gracious,
this?
what the fuck, bro?
This is sine of T over T. And then this is minus 1 over T squared. Yeah. I feel like this. I feel like this would blow up. Well, also this would blow up, right? Because then you have what is it? 1 over T squared. Sine of T over T minus 1. Oh man. So the question is like, does this go to 0 versus this? Yeah. I don't know how to do this with trick identities. I would do L'Hopital's rule for sure for it, but yeah, the question is like, do these things go to 0 faster than this goes to infinity? I don't know. Okay. Yes, Rocket Boy. If you want help with your question, there's a website, actualofficehours.com. Go check it out. I'm gonna pay a little bit more attention to the queue though, because we do have a lot in the queue. School year has started. Here we go. All right, let's go choose a winner for the next question.
Let's go gambling!
I'm getting like mocked hard. I kind of
Wait, Equity, I just did your question.
I'm making it too hard.
Wait, Equity, how'd you get picked again, dude? What? I just did yours. Oh, I see. You had 2 submissions, but they were probably like a very long time ago. Okay. Use paths. We don't get crazy here. All right. One sec. We can probably do this really quickly. All right. Determine whether it's continuous. I think what you do is you apply the limit at each side and just make sure that it goes to the same thing. So can you just do 38? Yeah, for sure. I can do that. Let's do this. So just doing this one. So what you want to show is, does the limit as x approaches 1 from the left, right? Because this is from the left of f of x, equal the limit as x approaches 1 from the right of f of x. I think that's like the definition of it being continuous, right? And does it also equal like f of 1? I think is the other thing. So the limit from the left is this one, because you're going from less than 1. So this is the limit as x approaches 1 of arctangent of x. Does that equal the limit as x approaches 1 from the right of ln of x? And, well, we didn't give a definition for f of 1, so, okay, we don't even have this one. We are doing math, Cole. Math. Okay, this one's easy, right? Because you can just plug that in. What's the ln of 1? ln of 1 is just 0. Okay. And then, what's the arctangent of 1? Well, that's where the opposite and the adjacent are the same. This is pi over 4. Right? So this doesn't work.
Oh, no.
So I would say not continuous, right?
Not represented as a Fourier series.
You wanted to represent it as a Fourier series as well? Stop, dude.
Oh, no.
You could.
Yes. Yeah. There you go. So that's the main thing you want to show. Is just that at x equals 1, these two things are not the same. You don't even need to do the limits, but this is the formally correct way to do it. Okay, cool. Nice. Another good one. That was fun. Thanks for reminding me that school starts this week. I'm sorry, dude. I'm very sorry, Mango. Sorry about that. All right, equity. Nice. Cool. All right, good. Let's mark that one as done.
Oh yeah, that just reminded me of something.
What's up?
You know how social media has basically destroyed the world at this point?
Correct.
I found a new, more nefarious way in which it is destroying the world.
Oh, please tell.
Seriously,
Please, pray tell.
you know that thing that keeps coming up with the saxophone.
What do you mean? Oh, when the saxophone noises start playing or
When
something?
the saxophone gets louder. That
Yeah,
kind of thing. Right? Do you know what that's from?
No, I actually don't.
I do, because I heard it the first time and I went, "That's not right." Right?
Where's it from?
There's a movie called Boys in the Hood.
Boys in the Hood. Okay, sounds like a 90s film or something.
Towards the end, where they're getting chased by the red car, that saxophone music starts playing, and then the guy gets a hole blown in his chest.
Oh no!
Like Boys in the Hood, like the 80s or 90s rap.
No, that was NWA, wasn't it? Or was that Eazy-E? But no, the movie.
We're talking about this one, right? Oh, I got an ad. When you try to make it out of the hood, but you hear the saxophone.
There's a gun shop on almost every corner.
Okay, but where's the scene though? That is cool. It has Ice Cube in it.
Towards the end of the movie.
Okay.
Yeah, here.
This is the scene. Okay.
Yeah.
Let's learn some history about like where this meme comes from. Oh, scratching some lotto tickets. Okay. Oh no. No, oh, I have seen this scene. I remember this is. Yeah. No, Ricky.
Somebody said.
Oh, they cut it. They cut it. Okay. But
Yeah.
we know what happens next.
The reason it's so nefarious is because it's being abused in a way where it's just like, I can't think of what the word is.
People don't know the meaning behind
sterilized.
it. It's it's
Shit.
oh,
fun.
man.
It's happy. It's not. There's no poignancy.
Normalized.
But the whole point in that scene was it was supposed to be very, very, very bad.
Sure.
You know.
I get it.
So it's
normalized.
It's a subtle way in which it will.
Or desensitized. Desensitized. That's the word we're looking for. Desensitized. Yes, we are desensitizing. We're sanitizing. Yeah, there we go. Interesting. Well, good.
Well,
Good
kind
to
of
know.
related. You're telling me that movie has nothing to do with the song "Boys in the Hood"? Because I always thought they were related.
Yeah.
Like I thought they were like.
It's a late 80s, early 90s phrase. Boys in the Hood. It means
Boys in the hood.
gangsters.
Gangsters.
Yeah, I know what it means. I
As
thought
my
they were
as my mother says,
connected
yabos.
in some sense.
Yobbos.
The yabos.
Not quite the same thing.
Yabos. All right, let's go spin the wheel. Who are we gonna get this time?
Let's go gambling!
See, I don't know whether you were here or you're too young, but
Pie. We got pie. What's up? Sorry.
But
What
yeah,
were you saying?
people genuinely did have automatic AK-47s.
Yeah, that was before the assault weapons ban
in-
in the
in
late
large
80s.
quantities.
Late 80s, I think, was the assault weapons ban,
It
right?
was a while back. You can still
It took
own
a,
them.
then it took
Yeah,
a
with
very
the-
long time for that to go away.
Yeah, it's you need like a big federal license for it or something.
Yeah.
Okay.
I still think that's unconstitutional.
crazy.
I don't know.
I would agree.
I don't think you need to
They didn't ask my
kill a
opinion.
deer. I don't think you need to kill a deer with like an M60. Like.
But that's not why you want a gun. You want a gun to kill a man.
Yeah, I know. Well, I mean, in England, the
Or a
argument is
tyrannical
hunting.
government.
Tyrannical government. Yeah, there you go. There you go. All right. If y is equal to, we might punt on this question because pi does give me some interesting ones, which I don't know if I can do them. First of all, I don't understand what's happening here. X squared plus, is this a squared to the what? What's going on here, dude? I can literally see the pixels.
I think it's just cut off. I think it's just. I wanna say
Learn
it's
to
one
take
of the
screenshots,
examples.
Bellend.
Oh no.
Yeah, sensational hunch you, dude. I think it's recursion. Yeah. X squared plus a squared. Yeah, but like, what's going on? Sorry. Find y to the n. Pi. Speak or forever hold your peace. What question did you just give us here?
It's like that weird Easter egg in Google if you type in recursion. Did you mean recursion? Did you
Oh
mean
yeah, that's
recursion?
always a good one. Yeah, I do like that. Yeah. Does it still work?
Yeah.
Oh my God! Stop! I don't want to use Chrome. Recursion. Did you mean recursion? Oh, dude, that's so good.
Also, do a barrel roll.
Was it do a barrel roll? Oh, no way. What? Oh, that's super cool. How do you know all these like Google tricks? That's fun.
Because they've been around for 20 years.
How does the spinning thing work?
You just say,
what do you do? I remember using to do it as a kid.
You just Google do a barrel roll. It's from Star Fox. It's a Star Fox meme.
It reminds me of was it like Sky King or whatever? That dude who stole that Alaskan Airlines.
Oh yeah.
And
Dude, yeah. He's a legend.
The ending was sad,
Sky
but
King.
he was like, he was so hyped. He's like, you think that I could do a barrel roll in
You
this?
think I could do a barrel roll in this thing? He's like, I know people down there are gonna be pretty mad, and I didn't mean to hurt nobody. I just, it's like that, and also who's it? The tractor guy, the bulldozer. What's his name?
Killdozer, Marvin Humar.
Killdozer.
I'm very. I used to live in Colorado, so
Yeah.
I'm familiar.
That's another fun story to like kind of look up. Yeah. Was it when an ordinary man gets pushed to unordinary circumstances, he must take unordinary like actions or something?
I forget what it was, but yeah, he armored it up. And
He armored it up and
got stuck in the basement.
Yeah. They eventually had a shootout or something.
Yeah, the government kind of fucked him, so he.
Well, the local government did.
He
All right, I'm
decided to fight back.
gonna punt on this question because I just don't know how to do it. Also, I don't know what the question is.
Was it?
It was pies. It's pies.
Well, he's not here, so fuck him.
Yeah.
Oh no.
Stop it, Aaron!
If you're not going to be here to have your fucking questions answered, fuck off.
Okay, here we go. All right, let's go.
Wasted my fucking time.
Let's go gambling!
All right, who we got next? Changing the order of integration. That is a good question. If you want to submit a picture of it, I'll do it. Ethan! Nice. You got selected, Ethan.
Well, at least you
Yes,
know Ethan's
sir.
here.
Yeah, we know
I'm still
Ethan's
here.
here. Great.
Time for some physics now.
Yeah, let's do some physics. I like physics.
Hopefully
What's up?
this keeps your mind at ease after what has been happening. Hopefully.
Okay,
It's not
let's do it.
too much of a headache, hopefully.
Ooh, you know what? This is actually almost exactly the same question I gave to my physics students when I taught mechanics last spring. Spring of 2025. I'm pretty sure I gave an exact question of this. Okay. What's up, Cody? It's probably Laplace. Yeah, maybe. For the last one, yeah. Okay, a snowball rolls off a barn that slopes downwards at an angle of 40 degrees. The edge of the roof is 14 meters above the ground. And the snowball has a speed of 7 meters per second just as it rolls off the roof. Ignore air resistance. How far from the edge of the barn does the snowball strike the ground? Cool. And then it says, okay, a 1.9 tall man is standing 4 meters from the edge. Will he be hit? That's a good question. Okay. So, I'm going to redraw some stuff real quick.
Yes, that's the goal. Like,
What's up?
like, what do people mean when they say like ignore air resistance? What does Doug want to do in this question?
Well, because air resistance would like screw up the trajectory of this thing, or the path, because it would act like friction.
So you would, so you would mean that how it would to be in free fall then? Like that means that gravity is solely acting on it, nothing else.
Correct. Yeah. Okay. Let me draw some angles here. Okay, because we said that the roof makes a 40-degree angle with like the building, like the horizontal. So that means this is also equal to 40 degrees. Let's try a little thinner of a pen so I got some space here. All right, so this is also 40 degrees. And then, so anytime you have stuff like going up and down, right, and going left to right, you want to really be careful and make sure that all of your velocities and stuff are broken up into just X direction stuff and just Y direction stuff. So we call this like, we got Sensation Black on duty. Yes, we did.
My man!
You want to break it up into components. So we say that the ball is falling with a speed of 7 meters per second, right?
Huh?
Okay. But that's going to have a certain amount of that 7 meters per second is going to be going left and right, and a certain amount is going to be going up and down. Okay.
So what does that do for?
Well, here, so we could call this like v naught x, right? And then we could call this v naught y.
You know why?
Good. And then we know that the ball starts 14 meters above the ground, right?
So v naught y could be equal to 14.
No. That's velocity. This is the distance, and so this is 14 meters. We could say that y naught is equal to 14.
Okay, but then what do we do from there?
Okay, good. So this ball, right, which is chilling up here, yeah, is gonna fall down. And it's gonna hit the ground right here at some point, yeah? And so what I want to do is I want to figure out how far it travels in this direction, okay? Based on the fact that I know how far it has to travel in the up-down direction. Okay. So let's say for instance, if I wanted to figure this out, if I wanted to figure out delta x here, let's say I wanted to figure out how much distance it traveled in the x direction. What's a physics equation you know that relates the distance something travels based on its like velocity and stuff?
Wait, are we talking about calculus like derivatives?
No derivatives. No, it's just simple kinematics. You could do this with algebra if you want.
Simple kinematics.
Yeah.
Wait, is it acceleration times time?
Close. That has to do with velocity.
Look, man, I don't remember those kinematic equations all the time.
Okay. Yeah, there. These are useful.
Oh, hold on. You are. So wait, we're trying to find delta x, the change when something's moving along like the air. So
yeah,
that knowledge, I don't think.
As this thing falls, right? I want to figure out how far it goes in x. Okay. Which equation here has like delta x in it, and things that I care about?
Well, what would that kind of seem tricky, but I would think maybe it's the third one, the bottom left.
Yeah, I like this one. I agree. The reason why I like this one, is it has the things I'm given, and it has things that I know I can figure out. So, for instance,
so wait, initial velocity, where's that?
So initial velocity, and this is in the x direction, right? That's going to be this one. This is, I guess, VIX, I should really call it to be consistent. What's up, Breasticles? Did I say something wrong?
I was going to say, wouldn't it be easier to use the second one, since we don't know what the time is just yet?
But then I would...
The second one.
Now, interesting. For the y direction, you're correct, Breasticles. But in the x direction, no. Because the acceleration in the x direction is what? That was my next point I was going to bring up. It's 0.
Oh, yeah.
Right? So if this goes away, I just get, final velocity equals initial velocity. That doesn't really tell me anything, right?
Yeah. I was thinking, I'd seen delta x, and I was thinking the same delta x.
Yeah, no.
I didn't even see that second. I didn't even see that the second one had a delta x.
Well, okay. So here's the main thing. So for objects that are in free fall, for objects that are just like chilling in the air, the acceleration only acts in the y direction, and that's gravity. So we can say that.
Gosh, 9.81.
Good. Yeah. So ax is equal to 0, and so if we use this equation right here, okay, I'm gonna find out. Oh, cool. Well, delta x is equal to VIX, so initial velocity in the x direction, times the amount of time it spends in the air, and then plus 1/2 AX time it spends in the air squared. But AX is 0. So this goes away. All right.
Oh, wait, so, why is AX already declared as 0?
Because in order for there to be acceleration, there needs to be a force. And if this thing is just in the air, the only force acting on it is gravity, and that force points down. It doesn't point left, it doesn't point right.
Oh, but if they gave you something like... So wait, if they told you that there was air resistance and they gave you some number,
that would fuck things up.
Back into the air.
Yeah, well, it'd be more complicated than that because the force of air resistance is dependent on the velocity, and then you end up getting a differential equation. So we don't want to solve that.
Goodness gracious.
We don't need to do that. Don't need to do that. Okay.
All right.
So what you should notice here, right, is that I can figure out delta x because I already have VIX, right? VIX is just going to be the component of this velocity in the x direction. but I need
How do you
t.
do components?
I'll get to components. Don't worry, we'll do that next. Okay, I need t. I need t, right? I need the amount of time that it's in the air, right? So this is in the air. How do we figure out the amount of time that's in the air? Well, now we're going to look at things in the y direction, okay, up and down. And this is where I probably want to use this equation. No, because I don't know the final velocity of breasticles. Actually, I don't want to use that. I don't want to use that one. I want to use this one.
Final velocity would be 0, or well,
No,
I guess final velocity would be right before it hits the ground. Yeah.
That is no. I'm glad you brought that up. That's a very, very valid mistake that people make all the time. They think that like, oh well, when this thing hits the ground, the velocity must be equal to 0. I mean, technically, yes.
That should be a thing.
Yes, when it hits the ground, it equals 0. But in physics, whenever we do kinematics things, we're always thinking about the instant right before it hits the ground.
Yeah, right before it.
Yeah, because technically
Why?
this thing has velocity right before it hits the ground. Yeah. It's not equal to 0.
Or we could do it with, the nonlinear acceleration as it
Yeah, that would be
randomly smacks
upsetting.
the ground. And, yeah.
It would be very upsetting. Okay. So it turns out, Ethan, we're gonna use the same equation. Cool. But we're gonna do it in the y direction. All right. So we're gonna say that delta y is equal
to the same exact thing.
But it's gonna be y direction stuff. So VIY times t
Over
plus
times c plus 1 times a times c squared.
AY times t squared. Yeah. Okay. So here's the key thing. In the air, AY is equal to negative 9.81.
Because gravity is going down, right?
Because gravity points down, yes, and it points down with the acceleration due to gravity, right, which is 9.81. Okay.
Okay.
What are some other things we know? Do we know delta y? I think we do.
Delta y? No.
How do we get delta y?
How do we know?
Well, delta y refers to the change in the y direction. What is the change in the y direction when the thing starts here and ends up in the ground?
14 meters.
Negative 14. Negative 14.
Oh gosh, right. That messes me up all the time. What?
You have to be careful with your signs here.
Cautious?
Yes, cautious. All right, so this is negative 14, okay? So then I have, okay, cool. Negative 14 is equal to
what is VIY?
We're going to figure out VIY in a second. Times t.
It's
and
t.
then this is going to be plus 1/2 negative 9.81 and then t squared.
Times t squared.
Yeah, good.
All right.
Okay. So, now, yeah, we should go figure out what VIY and VYX are, okay? This is a triangle, right? So, the 7 meters per second points this way at an angle, we say an angle of depression, which is equal to 40 degrees.
Yeah, I know that.
Okay. So then how would I figure out what this part is of the triangle if I know this is 7 and I know this is 40?
Then don't you use the SOHCAHTOA thing?
Good, SOHCAHTOA, yeah. Which one am I going to use?
And we always know 7 ms is hypotenuse, VIY is the opposite, and VIX is the adjacent. If we're trying to find VIY, I think we could do, hold on. The sine is equal to VIY all over 7. Could that work?
Right.
Sine
So
of
we
40 degrees?
could say sine of 40 degrees is equal to the opposite, which is VIY over the hypotenuse,
7,
which is 7.
Just 7.
And then we can just move that over, right? So do you see how VIY just ends up equaling 7 sine 40?
Yeah, I could try to figure that out right now. Hold on. What is that thing?
It's going to be, we're going to use our calculator later. It's okay. What would VIX be then? We'll use our calculator later. Like, this isn't a nice number. What would VIX be?
VIX. So since we already know 2 of them, we could do TOA. Tangent is equal to opposite over adjacent. Right. We could do that.
We could do that, but then we'd have to like throw this thing in as well. I think a better one would be let's use just the adjacent and the hypotenuse.
Yeah, cosine, like cos.
Good. Yeah, so this is 7 cosine of 40 degrees. Another key thing here, if ever like one of your components is sine, the other one's always cosine. If they're 90 degrees to each other, which they almost always are. Okay.
Wouldn't we also want to assign a negative to the VI?
I agree.
Good job.
I agree. Good job, breasticles. I almost made a mistake. This needs to be negative, Ethan. Because it points down. Right? You see that?
My goodness gracious, so many negatives.
It's okay. All right. So now we can take this information and plug it into here. And yeah, Jeff's right. Avoid rounding until the last step. Yeah, we don't want to do any rounding until the last step. So I'm going to do negative 14 is equal to negative 7 sine of 40 degrees times t. And then this is going to be minus 4.9 t squared.
Okay. Is this 4.905 then? Like negative 4.905?
Yeah. Yeah, technically, but let's just chill with that one. It's okay rounding that one. Okay. All right. So now, in order to solve for t, this becomes a quadratic. And so this is 4.9.
Oh gosh, not done.
This is 4.9 t squared plus 7 sine of 40 degrees times t minus 14 is equal to 0. Okay.
Wait, isn't it plus 14?
No, because there was a minus 14 here.
Wait.
I moved this over. I moved this over,
yeah.
Ethan. Okay.
Okay. I see.
This is the same thing as ax squared plus bx plus c is equal to 0. And so this, you need to solve this with a quadratic equation. I'm going to be lazy, and I'm just going to use my calculator to do it. You could go do the quadratic equation. No, I just don't want to do it. It's just a lot of time. Also, there's a lot of people in the queue. So the way I would do this is I would make like a cute little graph here. And I would say this is going to end up being... Let's really move this in the right place so people can see it. Ooh, okay, cool. So this would be 4.9 x squared plus 7 sine of 40 minus 4 times x, sorry. Gotta put an x in there as well. And then minus 14. And then I would just graph this. And then we also got to make sure we're in degree mode. I should have checked that earlier. Yeah, we're in degree mode. Cool. Great. So then from that, you see how there's two solutions for where this happens? Like there's two places that it crosses y equals 0.
Okay.
So we want to figure out the positive one because it doesn't make sense to go backwards in time. So I'm just going to do second calc. I'm going to say 0. I'm going to say the left bound is somewhere to the left of it, the right bound somewhere to the right of it, and that's going to give me a time of equal to 1.29. Okay. So from this, now I know that t is equal to 1.29 seconds. So now we can take this and put it into here. Okay.
Oh gosh.
And we're done. We're basically done here, dude. Okay, so now I get that delta x is equal to 7.
Is equal to what is
7 cosine of 40 degrees. And then this is times
1.29.
Good. Yeah.
If you did that, hold on. If you did that mathematical calculation, like, hold on, how does this even work? Let's see.
It's not too bad. You get 6.92.
I got 6.92. Yeah, me too.
Nice.
Good job.
There you go. Yeah, that's how you do it.
That's just for one question.
Yes. I will say though, like doing this one is not too hard. In this case, so notice how they said that the guy's standing 4 meters from the edge of the barn. So they're saying that like the dude's over here, and he's located.
He's 4 meters away from the edge of the barn.
4 meters away. You just want to figure out where the ball is when it's 4 meters away, and you want to figure out if the ball is above his head or below his head, and then because he's a total height of 1.9 meters.
But to be honest, I don't think it would hit him with this rate that it's going.
It's very easy to figure out. So for part B, all you have to do here is you have to figure out the amount of time it takes for it to go 4 meters in
The
the X
ball.
direction, which is this. So you say 4 is equal to 7
Is equal to
times t. So if we do
Times t,
4,
don't- Oh yeah, that one. Yeah.
right? 7
So 4
cosine of
divided
40.
by 7 times. Okay. Yeah.
So you get, this is equal to, you see that t is equal
Whatever.
to 0.75 seconds. Okay. And now you want to plug that into here to figure out what the y position would be. So you would say delta y is equal to, again, the VIY, which was -7
-7.
sine 40, right? Times 0.75. And then minus 4.9 times 0.75 squared. Okay. So -7 sine of 40.
I'm not trying to calculate it all.
Times
There you go.
0.75 is that, and then minus 4.9 times 0.75
0.75 squared.
Good. So let's see what we get. So we get -6.3. Okay.
6.1 for you, man. 1 tree.
1.3, sorry. Okay, so that means the ball has dropped 6.13 meters, but the ball starts 14 meters up. So even if it drops 6 meters, will it hit the guy here who's 2 meters tall?
No.
No. Because it would need to drop at least like 12.1 meters in order for it to hit the person, right? If they're 1.9 meters, right, then this would need to be 12.1 meters of drop. Cool.
Yeah.
Nice. Okay, cool. So yeah, the guy's safe.
Oh, that's pretty fun, you know. That's pretty fun.
It's a good question. I've asked this question before for my physics students. I definitely have.
Well.
So how would you
say
change
fun.
the 7 to hit the guy? That's a more complicated question. Good question though, Jeff.
No. What? No, don't complicate things at this point.
You would
No,
you would
no,
need
no,
to
no.
speed
We've
it
already
up,
got
right?
it.
I'm pretty sure. Well, actually,
I think
interesting.
you would want to slow it down.
Yeah, I think you actually want to slow it down, right?
Assuming that
Yeah.
the guy doesn't move, you would slow it down so it travels
Yes.
less
Yeah.
distance in the X direction.
Exactly. You're right. Yep. Yeah, you want to slow it down. Thank you, Jeff. That's a good follow-up question. That's a good follow-up question.
I was just asking, like, hold on.
Okay,
Like,
what's up?
if I have to do the 2 classes that are computer related, it's like I want permission from my mother, but she already gave up with the argument and just to do whatever I want. What if I
Okay.
what if I lose money? Because I want to like here's the thing with GUI programming. Then, if you want to call it that, I was afraid that this class was going to be hard. But looking at everything for the first class, first of all, we're going to cover content which might not be so bad because of learning in high school. And best, which is second of all, is that there's no exams. So like I want to stay in there, but then I kind of be wasting money because as like I want to switch to networking, but they don't even do GUI programming.
Yeah, networking and GUI programming are like 2 different things. GUI programming is Jeff says GUI programming is for the weak.
My name is Jeff.
Let's have a bit of clarity.
Yes.
GUI is design, not programming.
Exactly. Yeah. Well,
Even if you use code to write stuff for a GUI, it is still design work implicitly.
it's called UI UX, right? UI UX, I think, is the formal term for it.
That's the modern term, but that's slightly different actually. UI UX is specifically for touchscreens and stuff like that.
Mm-hmm. And also for like going around Amazon and stuff. Like, what color do we make the shopping buttons?
Don't use UI UX. Don't learn UI UX. It's pointless. It'll die very soon.
Yeah.
But I do want to say
You'll see.
in the GUI, I want to say in the GUI programming. So it's like, I feel like either way, I'm kind of wasting money.
Why are you wasting money? Sorry. Why do you think you're wasting money? Knowledge is never wasting money, unless you're like, I don't know, paying for like underwater or basket weaving or something.
I'm not gonna retake the courses, of course not. Like,
What
I'm
were
not
you
gonna
gonna
drop the
say,
courses. I'm
Sensation?
not gonna retake them.
Lesbian gender studies or something.
Lesbian dance theory.
Lesbian dance theory, yeah. That you'd probably be
I've
wasting
seen
money
it.
in that sense.
It exists.
I'm sure it does. I've no shade. If you want to like learn whatever, that's cool. Just don't expect a return on your investment.
Seriously though, what the fuck is lesbian dance theory? Just
I don't
learning how
know.
to
I'm not a
scissor.
lesbian and I don't dance. I'm sure it is something.
Oh.
But go on, Ethan.
Well,
Sorry.
I'll just have to like. Yeah, it's okay. So if you're saying it doesn't waste money and I get nothing back, I guess I could try, but my mother will not be happy with the results.
Yeah, I mean, just, sometimes you gotta like tell your parents that like, hey, like I'm a human. I want to like study stuff. I mean, you're not talking about like trying to like sneak out to go to a concert. You're asking to like take more math and science classes, which I think is totally valid and is not betraying your parents. You're trying to better yourself. So like, whatever, fuck it, do it.
You're just saying that it's
He's
a
in
waste
college.
of
There is
money.
no sneaking out.
There is no sneaking in. Yeah, there's no sneaking out in college. You're an
Well, no,
adult.
because he's in college. There is no sneaking out anymore.
Yeah. Have
Seriously
Dr.
though,
Gold
they
talk
said
to
my
them.
mother
I
said-
have talked to them before. Yeah, you could. Yeah, you
Yeah,
could
but-
have your parents call me. You want your parents to call me? They have my phone number. They can call me. I'll tell them what's up.
What are your parents
So, like,
demanding
wait-
from you?
Well, I
It's just
think
demand for me to finish this.
they just want him to finish. They just want him to like finish and like get a degree. And I understand. Like college is expensive. It's a big drain on like finances. So like I totally agree that they just want you to like focus on one thing and make sure you like graduate. That's totally valid. And what I was saying is that if you want to learn more things, I mean, you can still do this without paying, without costing your parents more money. You could also audit classes. That's like a totally valid thing to do as well. But yeah, that or you need to start taking out loans to do it yourself. Not
I have a
everyone.
job,
Good, then you can use your job to go take more classes. If you really feel strongly about
That's
it.
what I've been trying to.
Yeah.
That's what I've been trying to tell them. I literally have $5,000 in my bank account, but they are still complaining.
Yeah. Well, okay. I don't know. I would say you know what? Like get the degree. At least have enough credits to graduate, and you can tell your parents hey, I could graduate right now, but I want to take these more courses because it'll help me get a job later. And I don't think they would complain against that. I think once they see that you've already satisfied the requirements to graduate, doing anything else, especially if you're going to help fund it, is totally valid.
Well,
Yes,
I
and
guess I'll
guarantee
just join the two.
Yeah. You can join what?
Yeah,
Sorry?
I guess I'll join it. I think I'll join the two classes, the hardware fundamentals and the networking one. Not necessarily auditing them because then I'd be wasting my time. But I'm hoping that what I'm going to do is the right decision.
Okay, let us know. Okay, cool. All right, let's see.
Well,
I got
nothing to talk about. Later then.
All right. Later.
Thanks.
Peace, Ethan. Okay, let's see what we got. We got a couple more questions. Go spin the wheel. See what we get.
Let's go gambling!
My moment to shine. Thank you, Kaushik. Apparently, this is a 4 out of 10. Do we actually think this is a 4 out of 10 question, though? All right, let's see. If alpha is less than beta, which is less than gamma, which is less than pi over 2, then the equation 1 over x minus sine alpha plus 1 over x minus sine beta plus 1 over x minus sine gamma is equal to 0 has real and unequal roots, imaginary roots, rational roots, real and equal roots. Okay. Let me just kind of think about what the restrictions are, right? Because we're restricting all these angles between 0 and 90 degrees. So I guess we're at least restricting them to all be positive. The sign of those will all be positive, right? Yeah, we could do that. Let's do that. That's not a bad idea. So again, if this is theta and we're restricting to quadrant 1, then sine of theta will always be between 0 and 1. Yeah, right? That's the restriction. Okay. Yeah, I don't like them as individual fractions, so I am partial to the partial fractions. This devolves to a cubic. Yeah, let's see. Okay. All right. So we have... Is there a way I can just grab this text? I just don't want to grab all the other stuff as well. Okay, so we have this. And this was all equal to 0, right? Yeah, okay. So in order for these to have the same denominator, for instance, this one, so the common denominator would be equal to x minus sine alpha times x minus sine beta times x minus sine gamma. And in order to get those denominators, what we have to do is we have to multiply each term by the other two factors that aren't there. So this one has x minus sine alpha. So if I multiply it by this whole thing on the top, sorry, by just this on the top and on the bottom, I ensure that the denominator now is the whole thing, but then these two things are the only thing that are left up top. So this is going to be x minus beta times x minus sine alpha plus, so this one is the beta, so that's going to be the sine alpha and the sine gamma that survives. And then we're going to say plus, this is the sine gamma, so only these two need to get multiplied in. Right, and that's that. And that's all over this. And then this is all equal to 0. Now, cool thing here is now I can just cancel this out. So this whole thing can go away. Because I can just multiply to this side as well. And yeah, let's see what we get here. So when I FOIL this for each thing, let's see. And instead of like alpha, beta, gamma, I'm just gonna say ABC. Just because I hate drawing all those Greek symbols. You have to I was sort of wrong. You have to double check that x is never sine of one of those angles to avoid dividing by 0. Correct. You do need to check that, I guess, yeah. Right? Yeah, if sine of alpha is equal to x, then you end up getting 0 on the bottom, and you can't divide by infinity. It's bad. Well, I mean, let's check. Sorry, if x is equal to sine alpha, right? This is 0, but then some of these terms will be non-zero, right? I think we're okay. What you want to do is you want to make sure that you're not removing a solution that would be 0 over 0. What's up, Jeff?
Yeah.
Another Jeff.
My name is Jeff.
Wow, the Jeffs are multiplying. Yeah. Like, for instance, if you had, like, x squared plus 1. Or, sorry. X squared plus x is equal to 0. This is the same thing, right, as x times x plus 1 is equal to 0. If you divide by x, you get rid of this.
Emotional damage.
You would just get that, like, x plus 1 is equal to 0. The issue here is that you got rid of the solution where x was equal to 0. So, right, yeah. At least one numerator term on the top will survive. Exactly, I agree, right? Because none of these terms can be 0, Jeff. Which means that you'll never... You just worry about, am I removing the 0 as a root? But 0 can't be a root. Okay, so let's do this. So this is going to be x squared from these two. And then I'm going to say minus x sine b. Minus x sine c plus sine b times sine c. That's this one. Right, you could get 0 over 0. Correct, okay. And then I get another plus x squared. And then this is minus x sine a minus x sine C plus sine of A times the sine of C. And then from this one, I get plus x squared and then minus x sine A minus x sine B plus sine A sine B. And this is all equal to 0. Interesting. Okay, so x squared plus x squared plus x squared. So I'm going to get 3x squared. Let's group by terms, right? What other things do I have with x's in them? So all these middle terms, right? So that's going to be plus x. Or actually, here, let's group it this way. So I have a minus sine B, another minus sine B. So that's going to be negative 2 sine B, right? Negative 2 sine C, negative 2 sine A. Right? That's times x. And then plus, we're going to get sine A, sine B, plus sine A, sine C, plus sine B, sine C. And then this is all equal to 0. Okay, here's some important things. This is a quadratic, right? And I think usually when we have a quadratic, we want to check the what is it? The determinant, right?
The discriminant.
Sorry, discriminant. See, is discriminant like kind of like a determinant? I don't know. Not really.
They sound close enough that they're interchangeable in my mind.
Right. Okay. This is A, and then this is C. Okay. So yeah, what is B squared minus 4AC? That's the question. Okay. This is a huge mess.
You done messed up, Aaron!
I don't really want to do it. And then, okay, so...
You just substitute all your, like, signs and sine B and sine C to, like, a capital B or a capital C.
Yeah. I mean, so I also...
That at least makes it easy to figure out.
You know what's interesting here, Breskos? I have a minus 2 on all these, right? So this is going to be 4, right? And then I could say, like, sine A plus sine B plus sine C squared. Would that be the same thing as B squared? I think so.
Yeah, I think so.
And then we say minus 4 times 3. Femvox is calling A. All right. 4A, and then this is C.
I'm also calling it A.
So sine A. Okay, so I'm just going to write all this. I think I might call it as well for you guys. I don't know, actually. Okay. All right. Real unequal roots. I'm calling Packers by 4. Okay. All right. And we know they're like sequential, right? And they're all less than 1. So like the biggest this could get, right, is close to 3. I bet, right? And the closest this could get to is also 3, but this will always be less than this, right? Because all these other things multiplying it, they have to be like kind of less, I think.
Yeah, well, yeah.
Right? Like, I could try to get these things as close to 1 as I could, but then when I start multiplying them by things that are less than 1, it's still going to be less as well. I think that's my argument. Like, okay, so consider sine of x is less than 1. Then sine of x times sine of x is less than sine of x, which is less than 1. Oh, interesting. Oh, I see. So I think Femvox actually ends up like multiplying. You're multiplying these out, I guess, right? I want to say two real and unequal roots. I think it's this.
I also say it is.
Yeah.
I think.
Which is necessarily positive. Squares are positive, sum of squares are positive. Yeah. I think right. What did you do? Did you I think Femvox multiplied this out with itself. Which is kind of a mess. Oh, you know, actually it's not that bad. It's not terrible. Okay. Yeah, let's do that. All right, I think we can do this. This is not too bad. Okay. First of all, I notice there's a 4 on both of these, so I'm just going to pull that out. And then if I FOIL this, I'm going to get sine squared A, right? Plus oh man. Plus 2 sine A sine B, right? Plus 2 sine A sine C plus 2 sine B sine C, and then plus sine squared B plus sine squared C. Right, and then that's all minus 3 sine A sine B minus 3 sine A sine C minus 3 sine B sine C. Okay. Okay. Kaushik says is equal to 2 sine A minus sine B squared plus sine B minus sine C squared plus sine C minus sine A squared, which is greater than 0. Was I going to get the same thing? Maybe.
Probably.
Yeah. I'm curious to see how they actually got that. I guess you could like regroup things. Yes. Wait. This is actually really cool. Or is it cool? Because 2 sine A sine B minus 3 sine A sine B ends up being negative sine A sine B. But wait. I'm missing one of them though. Sorry.
No, it looks like you got them all.
Okay.
Maybe.
So this is minus sine A sine B plus sine B squared. I don't know. Yeah, this I have this minus sine A sine C minus sine B sine C, and then it's like plus sine squared B plus sine squared C. I'm like kind of seeing how this simplifies into those two things, because sine of A minus sine of B squared, that's equal to sine squared A minus 2 sine A sine B plus sine squared B. Like, cool. Which, yeah, I see that. You need a second one of these. So maybe you're taking, oh, I see. Maybe you're taking the 4 and you're putting in a 2. Oh, okay. I think I see it. Yeah, wait 1 sec. Let me do this. I'm going to say this is equal to 2. And then we're going to say this is 2, 2, 2, 2. Yeah, 2, 2. Okay. And then, okay, I see how this works. Okay, so if this is this, And then sine B minus sine C squared is equal to sine squared B minus 2 sine B sine C plus sine squared C. And then what was the last one? A minus B, B minus C, and then C minus A. I guess it doesn't matter. As long as you have all three. Yeah, this is cool actually. Or sorry, sine C sine A. Or yeah. Plus sine squared A. And yeah, look what happens. If you add all three of these together, there's my 2 sine squared A. There's my 2 sine squared B. There's my 2 sine squared C. And then there's my minus 2 sine A sine B, minus 2 sine A sine C, minus 2 sine B sine C. Okay, cool. That's really cool. Okay. So yes, this whole thing, okay, is equal to 2. That's really neat to, man, it's so many perfect square trinomials. That's cool. Good. Okay, cool. All right. And then, yes, these are all difference of squares. So these are always positive. And so the only way you could have repeated roots is if the discriminant was 0. And so that's why there's no repeated roots. That's why they're real. It's because it's always... JC's like, what the hell's going on?
No, God!
JC,
no,
it's
God,
okay,
please,
dude.
no! 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 No!
Anyways, yeah. So, cool. I agree. If the discriminant is positive, the roots have to be real, and they have to be unequal. This would be discriminant is less than 0. This would be discriminant was equal to 0. I don't really know why.
Because on the interval from 0 to pi, not including 0 and pi, any of those sine functions aren't going to output a
exactly a rational
number.
Yeah, I would say here, like, yeah.
And even if it did, it would still likely give you a irrational.
Sine is irrational.
Square root.
Yeah. Yeah, there's no way for like sine of x to equal x, right? Unless it's yeah. Jeff says wait.
My name is Jeff.
Jeff. What's the weight, dude?
About 200 pounds without a diet. Cha-ching.
200 pounds without a diet? Who's asking about that?
Weight.
Oh, wait. Yeah. Same. Sine of x is equal to 3/5 has a solution. Is it rational? It's a rational solution? Oh, I guess it is. No, it's not, dude. What? No. Jeff, that's not rational, is it? What's the arc sine of 3/5? It's not rational. It's like whatever, it's like 37 degrees or something, right? Oh, you mean sine can be rational? Yes, but I don't think there's any way for like oh, I see what you're saying. Alpha could be alpha. Wait, but sorry, you're right.
Yeah, sure,
Actually,
I guess it could be, but
I guess it could be.
I can't think of any way that it would produce a rational root when underneath the square root.
Yeah. Seems like it would just be a mess.
And even then, all we need is one counter example of an irrational root to say that is incorrect.
Okay, you guys want to ask chat? Let's ask chat real quick. Let's ask the clinker. Boom, boom, boom. I'm say like, I know The answer choice is A, but why can't there be rational roots?
I think me and Jeff came to the conclusion it's just because it's not always rational.
Oh, true. Oh, I see. You're just gonna go off based off
Just for not for every value on the interval.
right. Oh, okay, because alpha, beta, and gamma can be anywhere from 0 to pi over 2. Yeah, I got you. Yeah, real and unequal is guaranteed. Rational is not guaranteed. Correct. Could the roots happen to be rational? Oh, wow. So apparently this does work. So if you choose angles such that sine of alpha is 1 over 20, sine of beta is 1 over 5, sine of gamma is 9 over 20, these correspond to valid angles, okay? And then that reduces to one where the roots are rational. That's cool. So yes, it could happen. But it's not likely. And it's not guaranteed. Yeah. Nothing in life is guaranteed except like death and taxes. But yeah. Cool. It's a good question, Kaushik. Thanks, man. This is fun.
Sometimes death because you don't pay your taxes.
You should pay your taxes.
There are 3 things certain in life.
3 things are certain in life. Okay. What are the 3 things?
Death, taxes, and my anger.
Yes.
Give me coffee.
Give me coffee. I haven't had coffee in a while, actually. Okay, nice. This is a good one, Kaushik. Okay.
Gentlemen, this is Democracy Manifest.
Democracy Man. Where's that shirt from, dude?
Have you never seen?
No. A succulent Chinese meal? Wait, what? Where is this dude, I've seen this meme, succulent Chinese meal. What's that from?
In 1991, they arrested a fraudster and someone just so happened to be taking some footage. It was lost for like decades, and then somebody recovered it and dumped it online, and it became a bit of a meme. And the guy was like, "What is the charge? Eating a meal? A succulent Chinese meal?"
Okay, I think.
And
I've
it went
seen
on
this
news.
before.
You've probably seen the rest of it.
Oh, this is the guy that got arrested. He's like, "What is the charge? Eating a
Yeah.
succulent Chinese meal?" Oh, that's funny.
They caught up with him recently and did another interview, an interview with him. He's a complete nutcase.
Emotional, damn it!
Oh, I see. Oh, it's part of the video. Police forcibly detain him. He remarks in a stentorian. I don't know what a stentorian tone is. What's stentorian?
Wait, what?
Stentorian.
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 No, even I don't know.
Okay.
I don't know the word stentorian.
Apparently it's like senatorial. He says, "Gentlemen, this is Democracy Manifest. What is the charge? Eating a meal? A succulent Chinese meal? Get your hands off my penis."
You got messed up, Aaron!
And after an aborted attempt by a police officer to headlock him, "I see that you know your judo well." I want the original video now, though, dude. That's fucking hilarious. Okay. Anyways,
So of course I had to buy the t-shirt.
I like it. It's a great t-shirt. Okay. I do need to wrap up. Let's see. What questions did we not get to today? This one.
Just
oh, Jesus.
remind me of something before you crack on.
What's up? What's up?
Physics questions. There's 4 states of matter. Am I correct?
Yes. Plasma's the 4th.
Yeah. Just out of purely morbid curiosity, can any substance become plasma, or is there just particular
try hard
substances
enough,
that you
I
just can't pump enough energy into?
I think if you try hard enough, anything can enter a plasma state. There is.
I'm just curious if there's any substances which you just can't pump enough energy into.
Yeah. I mean, so they have like phase diagrams where like certain substances. No, because I believe for any amount of varying like pressure and temperature, you can access all the states eventually. There are things where, for instance, at like atmospheric pressure, it's impossible for things to exist as like a liquid, or it's impossible for them to exist as the good one here is like sublimation. So for instance, what is it? Like
transferring from
what is dry ice?
Immediately.
Dry ice is solid CO2, right?
Yeah.
Like, yeah, so CO2, solid CO2, at atmospheric pressure can only exist as either a gas or a solid, and it depends on the temperature. So there are certain phases of state that it can't access at a certain pressure. But I think once you get it to a certain whatever pressure you need, you can do it. Yeah, this is it, for instance. Where is this? It's a good question, actually, what you're asking. But so, for instance, yeah, this is the phase diagram of CO2. So atmospheres. So one atmosphere is like down here at the bottom. And so you notice that with temperature, you can only access the gas state and the solid state of CO2. It's not until you pressurize CO2, like put it into a tank, that you can then access the liquid state of CO2 at certain temperatures. Yeah. And so CO2 can definitely be a plasma. So the definition of plasma is really, it's just a gas that has so much electricity running through it that the electrons have been stripped free from their orbits, and they're allowed to just like go chill out with whoever else they want to. So it's called like an ionized gas. That's the definition of plasma, I think, if I know anything from my PhD. Yeah. You are right that like certain substances would be very difficult because first of all, you need to get them into a gaseous state. Like I don't know how to make like gaseous tungsten. That seems pretty excessive.
This guy stinks!
Somewhere in a star, presumably.
For sure. Yeah, and that's where like plasma states definitely exist. So, yeah, cool. Good question though. But yeah, let's see what else was in the queue. I do have to go, but let me see what we would have done. So this one, cool. Breasticles. What did you have for me? Ooh, Bessel functions.
Yeah, and I got mogged by the voting queue.
Why did it say? Why did it mog you? Oh, because 8 out of 10. Yeah, that was pretty difficult.
Yeah, I was the first one to submit. I had the most supers, and I still
Damn.
to like very bottom the whole time.
Well, Bessel functions are intense, dude. I barely remember doing Bessel functions in grad school, but we can
It's
try
only
next time.
kind of difficult.
Oh, this is a good question. This is an economics question. And Daddy also had economics question. Okay, cool. Well, all good. We'll still put them in our Discord, but yeah, if you want them to get answered during the stream, make sure try to ask them early on. And we'll do them. Okay, cool. All right, that being said, let's close that stream. Cool. All right, thank you everyone for coming to Actual Education Office Hours. Appreciate everyone who submitted questions today. I know we had a lot. We're getting back into the school year for things. Will we have a chess tournament this week or next week? I'm thinking, well, next week I'm going to Burning Man, so probably not next week. But I think we'll do. I want to do like a gaming tournament with you guys this week because we've done chess the last couple times. So maybe the week after. But yeah. The boiling point of tungsten. Yeah. But what's the vapor? Boiling point is from liquid to gas. Sorry. No, boiling point. Yes, is from liquid to gas. Oh my god, I need to stop.
Oh no.
My brain's done. Let's go say hi to someone else. Let's go stream. Let's go raid someone. But yeah, we'll have a stream tomorrow. Oh, that one will be an hour and a half earlier than usual. But again, always check the calendar. It has the most up-to-date schedule with what's going on. But so that one I think I have scheduled.
You said an hour and a half.
Well, because usually I would do it at 6, I think, but I'm doing it at 4:30 my time this time.
Well, for me it reads half an hour.
Oh, is that really only half an hour? I thought usually we did these at 6. Sorry, let me check. Sorry. Yeah, usually Tuesday would be at 6. I have it set for 4:30 now for tomorrow. So it's a half hour. It's a half hour. It's a half hour before what we did today, but usually Tuesdays we do an hour later. Yes, half hour before today's.
Right.
Correct.
Yeah.
Hour and a half before the usual schedule. Usually, I have Tuesday at 6 because Zach will stream from like 3 to 6, and I want to like not overlap too much with him so that we can like rate each other. Yeah. All good. So yeah, so coming by half hour earlier than what today's stream was. We'll still go for the full 2. Let's go say hi to someone. I have all these friends now on Twitch. Dude, what's this? This is a big shark. Let's go say hi to Casey. I like Casey. She's great. Go say hi to Casey. She's back from a convention. She's awesome. She's another great educational streamer. She does more like the art side of stuff. So take a break from all the math and science we've been doing today and go say hi to Casey. And I think art's still very important in life. So cool. All right. Enjoy the rest of your Monday. We'll see you tomorrow on Tuesday. Peace. Peace, everyone.